Hey guys, happy Monday and Dr. Seuss week. Go ahead and get your math notebook. We are continuing to work and look at our measurement. Now, so far we have only learned about customary or standard units of measurement. Today we're going to take a look at metric, okay? Metric is just different measurement units, okay? So we've done length before, but that was only in our custom standards for measurement, okay? So today we're going to go ahead and take a look at our metric, all right? All right, we've got two videos that we're going to take a look at. Lights, please.
Hi, this is Rob. Welcome to Math Antics. In this video, we're going to introduce the concept of measurement, which is an important topic in math, and especially in science. We're also going to take a look at a particular system of measurement called the metric system. Objects have different physical properties, right? Like size, weight, volume, etc. Well, the whole point of measurement is to quantify those properties, which just means expressing them as a number. Without measuring, you could say that someone is tall or short, or that a package is heavy or light, but those are relative terms that don't give us very specific information. Instead, if you were to make actual measurements, you could say that someone's height is 130 centimeters, or that a package weighs 5.2 kilograms. Measurements use an actual number to describe properties like that, so that you can know them more precisely. But there's a catch. Unless you know what a centimeter or a kilogram is, those measurements won't be very helpful. Centimeters and kilograms are examples of what we call units of measurement. Units of measurement are predetermined quantities that we use as references, and it's really important to be familiar with common units of measurement so you know what various measurements mean. Units of measurement aren't something fundamental to math, like addition and subtraction are. Instead, they're amounts that people invent and agree on so that we can communicate. In fact, we could agree to use just about anything as a unit of measurement. I could tell you that I'm 13 hot dogs tall, and my weight is 3,259 donuts. The problem with those units is that hot dogs and donuts aren't very consistent, and unless you and I are using exactly the same hot dogs and donuts to measure, we'll probably come up with different results. To get around this problem, the units that we use in math and science are standardized, which means that they match official standard amounts that can be measured over and over again to give exactly the same result. There's even a government agency called the Bureau of Weights and Measures that defines and maintains those standard amounts.
Well, what do we have here? Nothing, just measuring stuff. Let me see that. Ha! Just as I suspected, this isn't properly calibrated. I just had it checked. Yep, gonna have to take it into the lab for adjustment. Don't let it happen again. So, is there a number I call to get that back?
Of course, getting a bunch of different people to all agree to use the same standards is not always an easy task. And throughout history, a variety of different units have come in and out of popularity. For example, the ancient Egyptians used units like cubits and kites, which aren't so popular today. In modern times, there are still a lot of different units used in different countries, but the most popular system of units used around the world is called the metric system. Well, its official name is the International System of Units, or SI units for short, which stands for the French Système International. But the term metric system is still often used to refer to this system. The metric system is a really great idea because it makes the math involved with certain measurements and unit conversion much easier to do. That's because just like our base 10 number system, most units in the metric system take advantage of powers of 10. The idea behind the metric system is to start with a base unit and then use standard prefixes to make other units that are bigger or smaller than that base unit of powers of 10. Here's a list of some of those prefixes. To see how they work, let's consider a key unit in the metric system called a meter. A meter is a basic unit of distance or length, and it happens to be about this long. As you can see from our prefixes, a unit that's 10 times bigger than a meter is called a decameter. The unit that's 100 times bigger than a meter is called a hectometer. And the unit that's 1,000 times bigger than a meter is called a kilometer, or a kilometer. But this system also has prefixes to define units that are smaller than a meter. The unit that's 10 times smaller, or 1/10 of a meter, is called a decimeter. The unit that's 100 times smaller, or 1/100th of a meter, is called a centimeter. And the unit that's 1,000 times smaller, or 1,000th of a meter, is called a millimeter. Get the idea? There are also abbreviations for each of these units to make writing them down a lot more convenient. A meter is just abbreviated as M, and then you put other letters in front of that for the other units. For example, a kilometer is abbreviated KM, while a centimeter is abbreviated CM. So why does the metric system make working with units easier? Well, notice the pattern we get if we put these units in order with the largest unit on the left and the smallest unit on the right. Each unit is 10 times bigger than the unit immediately on its right and 10 times smaller than the unit immediately on its left. That's exactly the same pattern that the number places use in our decimal number system. This diagram can give you an idea of how the units relate to each other. For example, 1 kilometer is the same as 1,000 meters, and 1 millimeter is the same as 0.001 meters, or 1/1000th of a meter. And because all these different units of length are based on powers of 10, you can convert between them just by shifting the decimal point one place at a time, which is equivalent to either multiplying or dividing by 10, depending on which direction you shift. 2.754 kilometers is the same as 27.54 hectometers, which is the same as 275.4 decameters, which is the same as 2,754 meters, which is the same as 27,540 decimeters, and so on. You can convert to the next smaller metric unit by shifting the decimal point to the right, which is equivalent to multiplying by 10. And you can convert to the next bigger metric unit by shifting the decimal point to the left, which is equivalent to dividing by 10. For example, 9.8 millimeters is the same as 0.98 centimeters, which is the same as 0.098 decimeters, which is the same as 0.0098 meters, and so on. So you can see why the metric system is so useful. It was designed with our number system in mind, which makes it easy to work with. Oh, and even though the metric system defines a lot of different units with all these prefixes, not all are equally popular. For example, it's not very common for people to use decameters. They'll usually just say 10 meters or 25 meters instead of saying 1 decameter or 2.5 decameters. In fact, there's really just 4 metric units of length that are frequently used, and they are the millimeter, the centimeter, the meter, and the kilometer. Oh, and of course, nanometers are commonly used when referring to teeny tiny stuff like microbes or computer chips. A nanometer is 1/1 billionth of a meter. So that's how metric units of distance or length work. But there's another important quantity that uses the same powers of 10 prefix pattern, and that's mass, or weight. Mass is a measure of how much actual matter an object contains, which is closely related to its weight on Earth. In the metric system, the basic unit of mass, or weight, is technically the kilogram. But we're going to start with just the plain old gram to see how the same prefix pattern we use for length can be used for mass also. For reference, a gram is the amount of mass equivalent to 1 cubic centimeter of water. A decagram is 10 times bigger than a gram. A hectogram is 100 times bigger, and a kilogram is 1,000 times bigger. And similarly, a decigram is 10 times smaller, or 1/10 of a gram. A centigram is 100 times smaller, or 1/100th of a gram, and a milligram is 1,000 times smaller, or 1,000th of a gram. See, the same pattern is used, and all of these units of mass have abbreviations also. The pattern of abbreviation is similar to the metric units of length, but instead of an M for meters, you use a G for grams. kg is kilograms, mg is milligrams, and so on. Again, because these units of mass are based on powers of 10, you can convert between them just by shifting the decimal point. You can convert to the next smaller metric unit by shifting the decimal point to the right, which is equivalent to multiplying by 10. 5.24 kilograms is the same as 52.4 hectograms, which is the same as 524 decagrams, which is the same as 5,240 grams, and so on. And you can convert to the next bigger metric unit by shifting the decimal point to the left, which is equivalent to dividing by 10. 16.3 milligrams is the same as 1.63 centigrams, which is the same as 0.163 decigrams, which is the same as 0.0163 grams, and so on. But, as was the case with units of length, many of these units of mass are not used as often as the others. For example, centigrams aren't as popular because people will usually just say 10 milligrams or 25 milligrams instead of 1 centigram or 2.5 centigrams. The units of mass that you'll most commonly encounter in everyday life are the milligram, the gram, and the kilogram. So make sure you're familiar with those. All right, so that's a basic idea behind measurement and the metric system. Measurement helps us describe things in the world we live in and to compare them using units. And the units in the metric system are specially designed to play well with our base 10 number system. But it's important to know that the SI, or metric system, does use some units that are not based on powers of 10, like time, for example. The basic SI unit of time is the second, but units of time that are larger than a second are still the traditional ones that are based on the motion of the Earth and the Sun, like minutes, hours, days, and years. Fortunately, units of time that are smaller than a second do use the base 10 prefixes, such as milliseconds and nanoseconds. I wish I had more time to talk about time in this video, and all the non-metric units that are still commonly used today, like feet or pounds, but I'm afraid those will have to wait for future videos. There aren't too many exercises for this lesson, but if measurement and the metric system are new topics for you, you might want to give them a try. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
Alright, ladies and gentlemen, I usually only have one video for you guys on Math Antics, but I actually have two that I want to show you. One more in this one. Thank you.
Hi, I'm Rob. Welcome to Math Antics. In our previous video, we learned the basic idea behind measurement and the metric system. In this video, we're going to focus on some common units of distance to help you develop an intuition about their sizes and what sorts of things they're used to measure. As you probably know, distance is a one-dimensional quantity that describes how far it is between 2 points. Several different words are used as synonyms for distance, such as length, height, width, or depth. And the word you use usually depends on how an object is positioned relative to you. For example, if you're measuring a distance from side to side, you might call it a width. But if you're measuring a distance up and down, you'll probably call it height. But no matter which word you use for distance, the same kind of units apply. But as we learned in the last video, there's many different units of distance that we could use, such as meters, kilometers, or millimeters. And there are several other non-metric units of distance, like feet or inches, that we could use too. But why have different size units at all? I mean, wouldn't it be much simpler if we just picked one unit of distance and always used that one? Well, we could, but the main reason we have different units to choose from is that there's a huge variety in the size of objects that we might want to measure. Some are really, really big, while others are so incredibly small that you can't even see them. This wide range of possible sizes is called the relative scale of objects, and it's helpful to choose a unit of measurement that's a good match for a particular object's scale. Here's what I mean by that. Suppose I decide to measure my height using millimeters, which are really small units about the size of an ant. I would be about 1,980 millimeters tall. And while that's a correct measurement, it's kind of a big number that makes me seem even taller than I really am. On the other hand, if I decide to measure my height using a really big unit like kilometers, I'd be a mere 0.00198 kilometers tall. Again, that's a correct measurement, but it's a really small number that makes me seem tiny. But what if I choose a unit that's somewhere in between, like plain old meters? A meter is as long as this stick, which is why I like to call it a meter stick. And if I use it to measure my height, I'd be 1.98 meters tall, which is just a hair shy of 2 meters. So it would be fair to say that I'm about 2 meters tall, which is a nice, easy number to work with. See the advantage of having different size units for measuring distances? You can choose a unit that's relatively close to the scale of the thing that you want to measure, so that the numbers you get are more relatable and easy to work with. But that means that you need to know about the different units of distance so you can make a good choice, right? So that's what we're going to focus on in the rest of this video. Specifically, we're going to learn about 4 traditional units that are still used in America for measuring distances: inches, feet, yards, and miles. And then we'll see how those compare to the 4 most popular metric units for measuring distance: millimeters, centimeters, meters, and kilometers. Let's start with an inch. An inch is about this wide, which is pretty close to the width of a human eye, or perhaps the width of your thumb if you have big fingers. An inch is a good size unit for measuring objects that we commonly interact with. For example, a ping pong ball is about 1.5 inches in diameter, and my phone is about 6 inches tall, and an unsharpened pencil is about 8 inches long. And it's common to measure things that are smaller than an inch using fractions, like a 1/2 inch or a 1/4 inch. We'll learn more about fractions of an inch in a future video when we talk about measuring devices like rulers and tape measures. Okay, but what if we want to measure things much bigger than an inch, like a car? Well, we could still use inches and just end up with a big measurement, or we can use a bigger unit called a foot. A foot is exactly the same distance as 12 inches stacked end to end, so it's about this long. Some familiar objects that are approximately a foot long are, well, your foot for one thing. Of course, different people have different size feet, and most people have feet that are less than a foot long, but the length of the average shoe is a pretty good estimate for a foot. And that's why you'll sometimes see people walking off a distance heel to toe to estimate how many feet that distance is. Other things that are about a foot long are a foot long sub sandwich, a tall water bottle, or a 3-ring binder. And a foot is a convenient unit for measuring things like a person's height. I happen to be 6.5 feet tall. Or the width of a desk. Mine's about 5 feet wide. Or the length of a car. Mine's about 15 feet long. All right. But what if you want to measure something much bigger than a foot, like an athletic field? Well, that's what a yard is for. A yard is an English unit of measurement that's exactly the same as 3 feet placed end to end. So a yard is about this long. In general, yards aren't used as often as feet, but one place where yards are used all the time is in American football. Between the end zones, an American football field is 100 yards long, and those 100 yards are divided into subgroups of 5 yards each. So you can measure some pretty big distances with feet and yards. But what if you need a unit that's even bigger? Well, that's where miles come in handy. A mile is equivalent to 1,760 yards. That's the distance you would get if you put 17.6 football fields end to end, which is pretty far. A mile is much bigger than the other 3 units we've looked at so far. If this is an inch, then this is a foot, and this is a yard, then this is a mile. Because miles are so long, they're mainly used to measure distances between various places on Earth and how far people travel. For example, the distance from New York City to Washington, D.C. is roughly 200 miles, as the crow flies. And the distance from the east coast of the U.S. to the west coast, or the best coast, whichever you like to call it, is over 2,600 miles. Sure, you could use miles to measure smaller distances, but it'd be a little silly to tell your friend that you're 0.000994 miles tall, but go ahead if you want to. Okay, so that takes care of the 4 main traditional units. Now let's have a look at the 4 most common metric, or SI units of distance, which are preferred by the scientific community and most countries. We're going to start with a unit called a centimeter. A centimeter is pretty small. It's approximately the width of your pinky finger or the diameter of a small marble. If you compare a centimeter to an inch, you'll find that it takes about 2.5 centimeters to equal 1 inch, 2.54 centimeters to be exact. So centimeters are also really good units for measuring objects that you commonly interact with. This rechargeable battery is about 5 centimeters long. This tennis ball is about 6.5 centimeters in diameter. And this flashlight is nearly 23 centimeters long. Wow. But what if you want to measure things that are smaller than a centimeter? Well, millimeters might be a good choice. A millimeter is exactly 1/10 of a centimeter. That means if you took a centimeter and divided it up into 10 equal parts, each of those parts would be the distance of 1 millimeter. A millimeter is about the width of a small black ant. So millimeters are good for measuring small things, like the width of a sunflower seed or the thickness of a smartphone. Okay, but what if we need to measure something bigger than a centimeter? No problem. We can just use meters. A meter is a unit of distance that's about this long. That looks similar in length to a yard, doesn't it? It turns out that a meter is just a little longer than a yard, approximately 10% longer. But the important thing to know about a meter is that it's the exact distance you'd get if you took 100 centimeters and placed them end to end. Yep, 100 centimeters equals 1 meter, which means that a centimeter is 1/100th of a meter. Meters are great for measuring distances like the height of a building. This one is 381 meters tall, or the distance around a racetrack, which is 400 meters. But if you needed to measure even longer distances, you could use kilometers or kilometers. A kilometer is the distance you'd get if you took exactly 1,000 meters and placed them end to end. That's a long distance. It's much longer than the other metric units we've seen. If this is a millimeter, this is a centimeter, and this is a meter, then this is a kilometer. As you can see, a kilometer is in the same scale range as a mile, but a mile is even longer than a kilometer. In fact, it takes just a bit more than 1.6 kilometers to be the same distance as a mile. And because they're big like miles, kilometers are also primarily used to measure distances between different locations on the Earth, or even in space. For example, it's about 4,000 kilometers from the east coast of Australia to the west coast, and it's approximately 384,000 kilometers from the Earth to the moon. Okay, so now that you have a better idea about the size of the most common traditional and metric units of distance, let's do some side-by-side comparisons so you get a better feel for how these units relate to each other. Again, let's start with an inch. We already learned that an inch is the same distance as 2.54 centimeters, right? So how many millimeters would be equal to an inch? Well, since there's exactly 10 millimeters in each centimeter, all we have to do is multiply 2.54 by 10, and we see that there are 25.4 millimeters in an inch. But now, let's bring in a foot. We know that there's exactly 12 inches in a foot, which means that a foot is 12 times longer than an inch. So, how many centimeters are there in a foot? Well, since there's 2.54 centimeters in an inch, if we multiply that by 12, we'll know how many centimeters are in a foot. Using my trusty calculator, 2.54 times 12 equals 30.48. So a foot is exactly 30.48 centimeters long. Those are exact conversions between inches, centimeters, and feet. But what if you only need estimates or close enough measurements? In that case, just remember that an inch is about 2.5 centimeters, and a foot is about 30 centimeters. Let's do another quick comparison, starting with 10 centimeters instead. If you have 10 centimeters, it's easy to see that it's equivalent to 100 millimeters, since there's 10 millimeters in every centimeter. 10 times 10 equals 100. But what would that same distance be in inches? Well, an inch is bigger than a centimeter, and it takes approximately 2.5 centimeters to equal an inch, right? So if we divide the 10 centimeters up into groups of 2.5, which is the same as dividing 10 by 2.5, it forms 4 equal-sized groups. That means 10 centimeters is very close to being the same as 4 inches. The reason it's only very close is because we use the estimate 2.5 centimeters per inch instead of the exact value of 2.54. If we divided 10 by 2.54 instead, you'd see that 10 centimeters is more like 3.937 inches. But 4 is a great estimate, and it's easier to remember. 10 centimeters is about 4 inches. Now that we've compared some of the smaller units, let's briefly look at the bigger ones. We learned that a meter is about 10% bigger than a yard, or roughly 1.1 yards. That's a good estimate, but more precisely, to 3 decimal places, a meter is 1.094 yards. A yard is 3 feet, so that means a meter is a little more than 3 feet. How much more? Well, each foot in a yard is 12 inches, so a yard is 36 inches, since 3 times 12 equals 36. Our estimate is that a meter is 10% bigger than a yard. So, what's 10% of 36 inches? Yep, 3.6 inches. And if we add that to 36 inches, that means a meter is pretty close to 39.6 inches, or 40 inches if we round up a little. And that checks out, because remember, we just estimated that 10 centimeters is about 4 inches. Well, a meter is 10 times as long as 10 centimeters, and 40 inches is 10 times as long as 4 inches. So a good rough estimate of a meter is that it's about 40 inches long. Last of all, let's compare a kilometer to a mile. A mile is longer than a kilometer. In fact, it takes approximately 1.6 kilometers to equal 1 mile. The exact value is 1.609344. That means that a kilometer is only about 62% of the distance of a mile. A good way to remember the estimated difference between a mile and a kilometer is to multiply both by 10 and remember that 10 miles is roughly the same distance as 16 kilometers. That fun fact may come in handy on your next road trip.
Oh, we should be at the campsite in 16 kilometers. 16 kilometers? We're never gonna get there. Oh, chill back there. That's only 10 miles. Yes.
All right, so that's a basic overview of the most common units used to measure distance. Hopefully, it's given you a better idea of how big each unit is, how the various units relate to each other, and what sorts of objects they're helpful for measuring. Again, there aren't too many exercises for this section, but
All right, ladies and gentlemen, lights, please. Actually, do just the right light for a minute. All right, so longer videos than what we normally do from our Math Antics friend Rob, but I thought he had some good information that we need to see. This afternoon, and this morning, you guys need to save metric units of length image on your iPad. This is going to be our chart that we're going to be using today to be converting our metric units of length. All right, save that to your iPad. All right, both lights now, Malia. All right, let's do some problems here together. centimeters equals blank meters. All right, let's go through our rules here. Am I going from a bigger measurement or to a smaller measurement?
Smaller. No bigger.
Oh, I hear both. I hear small to big and I hear big to small. Are we sure here?
Small to big. Small to big.
Discuss it with somebody next to you right now. Am I going small to big or big to small? All right, tell me now, small to big or big to small? Small to big, very nice. So I'm going from a smaller unit to a bigger unit. And when I go from a smaller unit to a bigger unit, what kind of computation am I doing? Division or multiplication? Charlie? All right, well, let's look at our chart here. Does my chart tell me how many centimeters in a meter? It does. How many centimeters to a meter? 100. So I need to take 1,000 times 100. I feel like we've got an error somewhere, guys. I feel like we have an error. Sophia, what do you think?
Small to big is dividing.
Yes, small to big is not multiplication. Small to big is division. Very nice. A smaller unit to a bigger unit should be division. Very nice. So instead of 1,000 times 100, what's that going to be?
1,000 divided by.
1,000 divided by 100. This should be mental math. What is 1,000 divided by 100? 10. Very nice. All right, let's slide on over. Number 2. Let's do 58 meters. want you to try that one on your own right now. One more minute.
This is Bush. Can you
Yes.
zoom in that?
Ooh, on our chart? Yeah.
Oh yeah. No, it's on Schoology.
Yes, the chart is on Schoology. You can save it, but I will zoom in as well. There we go. All right, let's check this one. Meters to millimeters. Am I going from a small unit to a bigger unit or a bigger to a smaller? Bradley,
Bigger to a smaller.
what do you guys think? Is he right? When I go from a bigger unit to a smaller unit, what kind of computation does that get? Multiply. Good. So looking at my chart, I'm looking for millimeters and meters. Let's scroll up here a little. There we go. Millimeters to meters. Do I see that on the chart? Yep. 1 meter is 1,000 millimeters. 1,000. So I need to do 58 times. Yeah. 58 times 1,000. This should be mental math. What is 58 times 1,000?
58,000.
Very nice. Ladies and gentlemen, remember on your homework, if it's a Schoology worksheet, I will always go back and regrade labels myself, okay? So no need to worry about that. Number 3. Centimeters equals how many millimeters? I want you to work with somebody in your area on this one. Work with somebody in your area. Staying in your seats. Discussing with a friend. Mask on for this.